All right, we've done some serious graphing with falling objects. Today, let's get into some math. No one really discovered gravity. We all know that when you drop something, it falls down. When you jump, you come back to the earth. That's kind of a normal thing. But one of the first people to really think about it was an ancient Greek philosopher. A philosopher was actually somebody who just thought good things. And if you could think good things and people would listen to you, you were a philosopher. People philosophized about all kinds of things. You could philosophize about religion. You could philosophize about society. If you were philosophizing about nature, you were called a natural philosopher, which is actually the precursor to science. One of these great philosophers was by the name of Aristotle. Aristotle was actually a third-generation philosopher. You may have heard of Socrates. Socrates was the guy with the Socratic method. He would sit on the steps of the academy in Athens and just preach about different things. Socrates had a prime student named Plato. Plato was actually the head of the first university in the world, one called the Academy in Athens. And Plato had all kinds of great ideas. He had a prodigal student named Aristotle. Aristotle was kind of the golden boy of the university. And what Aristotle said kind of went. Like, people just bought into it. He was a third-generation philosopher. He had great teachers. He ended up tutoring Alexander the Great. I mean, this was the guy, right? Well, Aristotle had this idea about gravity. He said that if you dropped a feather and a chicken, the chicken's going to hit the ground first. Okay, so I think we all kind of figured that out. And what he said is, it's because the chicken's heavier. And if you were to drop something and continue to drop something heavier and heavier and heavier that are more dense, it would go faster and faster and faster. And this idea that the weight based on the amount of air resistance between it has to do with the speed at which it falls. So he had theorized that there's no such thing as a pure vacuum, meaning that if you were to drop this chicken in a vacuum, it would go infinitely fast, which then he says that cannot actually happen. It's a pretty big thought for 500 BC. Now, Aristotle's ideas were actually picked up by the Roman Catholic Church and held through what we call the Dark Ages. The Dark Ages are the time in history where there really wasn't a lot of new thought because the church doctrine kind of dictated a lot that was going on. And you really don't talk against church doctrine and dogma. So the Dark Ages didn't have a lot of new ideas. The Dark Ages actually ended with a period called the Renaissance. This is where people started to question some of the things that the church believed. Remember, the church's stuff was all based on Aristotle, or a lot of it was based on Aristotle. They started looking at planets that are going around the sun and starting to think about, do they go around the sun instead of the earth? And different things like that. One great thinker that started to challenge things was a guy by the name of Galileo. Galileo was what we consider the first physicist. Galileo actually was working in Pisa, kind of like the Leaning Tower city in Italy. And he was a pretty big deal. And when he was in college, he started to question some of his professors that were talking about gravity. And he did a rather famous experiment. So Galileo actually started to do some work with gravity. He started to question Aristotle's ideas with things falling down. Now, if you want to measure motion back in the Renaissance, you didn't have a stopwatch. He didn't have very good measurement techniques. So what he did, however, was really pretty ingenious. Galileo was a trained musician. In fact, his father was like a lute player for the king. His musical ear actually allowed him really to understand cadence, this idea of things that happen in a pattern. So what he would do is he would take an inclined plane, something like this, and he would lay lute strings across the inclined plane. And when he would drop a ball down the inclined plane, it would ting these lute strings. And as it did that, he could listen for the cadence and make sure that they were happening at the same pace all the way down. He would adjust the distance of the lute strings in order to get that proper cadence down the string. This allowed him to figure out how things are accelerating down this inclined plane. Then he would turn his inclined plane a little bit steeper. and see what happened. He would drop lighter balls and heavier balls. He would do all these things until he figured out that when he put his inclined plane straight up and down, something remarkable happened. So Galileo would say that if I drop these two balls, we would know that they're both going to fall actually at the same rate. So if you look at these two balls, we drop them, and they fall down at the same rate. They actually hit the ground at the same time. What Aristotle believed was that heavier balls would fall faster than the lighter ball here. So if I grab a heavier ball, be it a softball here, and I drop these, Aristotle would say that the heavier ball would fall a lot faster. Let's take a look and see what happens. They actually fall at the same rate. Galileo showed that all things fall at the same rate. If I were to jump off of here, I would fall at the same rate as the ball. Now, what about this idea of the feather and the chicken? Well, we know that when we drop the feather and the chicken, that the feather hit first. Galileo said, well, that's because of air resistance. If I take that idea of the feather, which this paper kind of represents, and lessen the amount of air resistance that's going on with it, meaning making it a little smaller, this is the same mass that it was before, okay? As if a paper would fall by itself. If I take this with my chicken, they fall at the same rate, which is much different than the paper if it's falling without it. So Galileo found out that everything fell at the exact same rate. Now on Earth, we know that that rate is called g. We call it lowercase g. If you ever see a g, a lowercase g on this board, it's going to mean negative 9.8 meters per second squared, almost negative 10. Now what that means is after 1 second, the object's going 10 meters per second, roughly. After 2 seconds, almost 20. After 3 seconds, almost 30 meters per second. It accelerates on its way down. Now we're ignoring air resistance in this situation, which we'll do as a class for most of the time. We may add air resistance in when we start talking about forces, but for right now, we're going to assume things are falling in what we call free fall, meaning accelerating at negative 9.8 meters per second. Today, you're going to practice this a lot. So the worksheet that goes along with this video really is just a whole bunch of math problems to help you practice using those kinematic equations, all of those different ways in solving for variables that we can look for in physics. The difference with these is this is going to work with things that are always falling. If it's falling, you know right away the acceleration. Okay? So that's a variable that's kind of a given. Even though it's not labeled in the problem, it's kind of implied that this is a thing. So good luck on your worksheet. If you have any questions, please reach out. I know there's a couple of tricky ones on there that you're really going to have to think about. Have fun, and I'll see you soon.